Okay, today's video is 1.4 and it's about using the laws of exponents to find powers of monomials. So I need you to write, I can use laws of exponents to find powers of monomials. I can use laws of exponents to find powers of monomials. Okay, so this is really pretty easy if you remember from last time. So let's talk about this. Let's do an example before anything. So 6 to the 4th raised to the 5th. Let's expand this and see what it would look like. That would be the same as 6 to the 4th times 6 to the 4th times 6 to the 4th times 6 to the 4th. That's 1, 2, 3, 4. One more times 6 to the 4th. Okay, but what did we learn last time in our videos? That when we have the same base, we can add them. So this would be 4 plus 4 plus 4 plus 4 plus 4, which would be 6 to the 20th. So all we're really doing is we're multiplying 4 times 5, because 4 times 1, 2, 3, 4, 5 to give us 6 to the 20th. Another example would be 8 to the 4th cubed, which would be 8 to the 4th times 8 to the 4th times 8 to the 4th, which would just be 8 to the 12th. And one more example, if we had k to the 7th raised to the 5th, this would be k to the 7th times k to the 7th times k to the 7th, k to the 7th, 1, 2, 3, 4, 5, which would be k to the 7 plus 7 plus 7 plus 7 plus 7, or k to the 7 times 5, which would be to the 35th. So I want you guys to try these for me in your notebooks. 2 to the 5th squared, w to the 4th to the 6th, and here's one, 3 squared cubed, and then all of that in brackets squared. So try those 3 in our notebooks. And then what I want you to do is I want you to write a rule to describe this. Okay? So I need you to write in your own words what rule you have to describe this. Now, if we continue on, the last thing you guys need to know about this is if I have in the parentheses more than one variable. So if I have 6x squared cubed, this is going to go, this cubed needs to go to the 6 and the x squared as well. So this is the same as 6x squared times 6x squared times 6x squared, which we could group these 6's, 6 times 6 times 6, couldn't we? And we could group these x squared, so we'd have x squared times x squared times x squared. Or in other words, 6 cubed, x squared cubed. And from here, we would then have, this would be 6 cubed still, and this would be x to the 6th, or 2 plus 2 plus 2, which would be x to the 6th. So what we need to know is that this exponent goes to both the number and to the variable. So let's give you another example. 4p cubed raised to the 4th. This is the same as 4 to the 4th, p to the 12th, which, if you type that into your calculator, you should get 256 p to the 12th. Here we go, let's do one more. Negative 2m to the 7th and to the 6th raised to the 5th. So this is the same. We could write this out 5 times, or we could know that this needs to go to each and every one of these. So this needs to go to negative 2 to the 5th, m to the 7th to the 5th, and n to the 6th to the 5th, which will be negative 2 to the 5th, which is 32, negative 32, because there's an odd number of negatives, m to the 35th, n to the 30th. Okay, I have a couple that I want you to try. Try 8b to the 9th raised to the 2, or squared. 6x to the 5th, y to the 11th to the 4th, and negative 5w squared z to the 8th cubed. Okay, that's all I have for you guys today. I will see you soon.